Grignard reaction by Jamisha Schaefer. What is a Grignard reaction? The Grignard reaction is an organometallic chemical reaction in which electrophilic carbon atoms within polar bonds are attacked by alkyl or aryl magnesium halides. Nucleophiles are Grignard reagents. A carbon-carbon bond is formed through the Grignard reaction. It affects the reaction center's hybridization and the creation of carbon-carbon bonds. The Grignard reaction is a useful technique. Carbon phosphorus, carbon 10, carbon silicon, carbon boron, and other carbon heteroatom bonds can also be formed. As shown in the picture, formaldehyde produces a primary alcohol. Aldehyde produces a secondary alcohol, and ketone produces a tertiary alcohol. Formation of Grignard reagents. The addition of magnesium metal to alkyl or alkynyl halides produces Grignard reagents. Chlorine, bromine, or iodine can be used as the halide, but not fluoride. However, making Grignards from iodides and bromides is slightly easier. Reaction of Grignard reagents with aldehydes to give secondary alcohols. The reaction of Grignard reagents with aldehydes and ketones to generate alcohols is one of their most prevalent applications. The Grignard produces the carbon-carbon bond in the first step. As a result, an alkoxide is formed, the conjugate base of an alcohol. The addition of acid towards the end of the reaction is required to create the alcohol. Addition of Grignard reagents to epoxides. Grignard reagents also react with epoxides to generate carbon-carbon bonds, which is an important reaction. One thing to keep in mind is that they tend to add to the epoxide less substituted end, which is also the least sterically inhibited end. This reaction is essentially the same as an SN2 reaction. Alcohol is obtained after the addition of acid. Making a Grignard reaction. Grignard reagents are created when an alkyl or aryl halide reacts with magnesium metal. The reaction is carried out by mixing the organic halide with a magnesium ether solution, which provides the ligands needed to stabilize the organomagnesium molecule. Diethyl ether and tetrahydrofuran are calming solvents. Grignard reagents are incompatible with oxygen and product solvents such as water or alcohols. Single electron transfer is used to carry out the reaction. Grignard's reactions frequently begin slowly. First, the reactive magnesium is exposed to the organic reagents for an induction phase. The reactions might be substantially exothermic after the induction time. Bromides and iodides of alkyl and aryl are frequent substrates. Chlorides are also employed, but fluorides, with the exception of particularly activated magnesium, are generally non-reactive. Importance of Grignard reactions. Grignard reactions are one of the most efficient methods for producing carbon-carbon bonds and linking alkyl chains in organic chemistry. Grignard reagents, for example, are often employed to alkylate aldehydes and ketones. Grignards are one of the few reagents accessible to chemists that can produce carbon-carbon bonds as well as Grignards. The metal-carbon connection in Grignard reagents is extremely ionic, and carbon is more electronegative than magnesium. These carbanions are very nucleophilic and react rapidly with electrophilic groups like carbonyl groups. Grignard reagents generate primary alcohols from formaldehyde, secondary alcohols and ketones from aldehydes, and tertiary alcohols from esters and acid halides. Grignard reagents are used to make amines, ketones, nitriles, thiols, aldehydes, and other organic compounds. Grignard reagents can generate carbon heteroatom bonds with a range of halides. Stereochemistry in Grignard reaction. If the attacking Grignard doesn't have the same R group as the carbonyl, asymmetrical carbonyls can produce chiral compounds. As a result of starting with the sp2 hybridized carbon atom, any chiral compounds generated will be a racemic mixture. sp2 carbons are trigonal planar, which is in flat, and distinct stereoisomers can be addressed from the top or bottom. Why is a Grignard reagent so reactive? Because the Grignard reagent carbon atom has a partial negative charge, it behaves like a carbanion and reacts with electrophiles. Grignard reagents are highly reactive reactants that are used to create new carbon-carbon bonds in synthetic reactions.